Welcome to the lesson on key battery terminology. In this lesson, we will explore the essential key terms that will help you gain basic knowledge about the key elements related to electric vehicle, abbreviated as EV, battery terminology. It is important to understand that batteries play a crucial role in the functioning of EVs. Keeping that thought in mind, let us look at our lesson objectives. By the end of this lesson, you will be able to identify the key terms associated with EV batteries. This will enable you to recognize the terms and decipher the technical jargon related to EVs. Next, you will be able to describe key terms used for EV batteries. This will help you to grasp the meaning and comprehend the functioning and components of EV batteries more effectively. There are several terms associated with EV batteries. In this lesson, we will focus on some of the battery key terms, namely electrolyte, electrode, lithium-ion battery, battery pack, battery management system, abbreviated as BMS, state of charge, abbreviated as SOC, and battery range. By understanding these key terms, you will be better equipped to comprehend EV batteries. What is an electrode? If you think of an electrode as being an electric rod, you are close. Another clue comes from the origin of the name. Road means a pathway in Greek. Hence, electrodes are conductors through which electricity enters or leaves a substance or an object. The electrode from which electrons emerge is designated as negative. The electrode that receives electrons is designated as positive. In conventional current flow, the direction of electric current is from the positive terminal of a voltage source to the negative terminal. However, the direction of electric current in EV batteries is from the negative terminal to the positive terminal. Electrodes in EV batteries are essential because they enable the flow of electricity within the battery, determine the storage capacity, and contribute to the stability and durability of the battery. So, what is an electrolyte? The electrolyte is an essential part of a battery. Without the electrolyte, the battery would not be able to function. It is a substance that allows electrical current to flow between the two electrodes. The electrolyte is usually a liquid, but it can also be a gel or a paste. When an electrolyte is dissolved in water, it splits into positively and negatively charged particles called ions. These ions are then able to conduct electricity. The electrolyte enables a chemical reaction between the positive and negative electrodes. A chemical reaction is created by an electrolyte between two dissimilar metals. One terminal becomes more positive and one terminal becomes more negative. During discharge, electrons flow from negative to positive in the circuit. The flow from negative to positive is reversed during charging. Inside the battery, ions flow from the positive to the negative terminal during discharge, and during charge, the flow is reversed. An electrolyte is a critical component of lithium-ion batteries used in EVs. The composition and properties of electrolytes play a crucial role in the EV battery's performance, safety, and longevity. Let us look at the lithium-ion battery. These batteries are the primary battery for many consumer types of equipment, such as cell phones, battery-powered tools, and computers. A lithium-ion battery's three primary functional components are the positive and negative electrodes and electrolytes. Generally, the negative electrode of a conventional lithium-ion cell is made from carbon. The positive electrode is a metal oxide, and the electrolyte is a lithium salt in an organic solvent. The electrochemical roles of the electrodes reverse between anode and cathode, depending on the direction of current flow through the cell. Lithium-ion batteries can be dangerous under some conditions and pose a safety hazard since they contain, unlike other rechargeable batteries, a flammable electrolyte and are also kept pressurized. A lithium-ion battery is a rechargeable battery that is made up of cells. These cells move from the negative electrode through an electrolyte to the positive electrode when the battery is being used up, and then they move back when it is time for a recharge. The lithium-ion battery is the current standard in most EV batteries. These batteries can store a whole lot of energy. A properly maintained lithium-ion battery is good for 8 to 10 years. Let us now look at the battery pack. It is one of the key components of an EV. Picture it as a collection of interconnected lithium-ion battery cells working together to store electrical energy. Imagine you have several regular AA batteries that you use for a TV remote. Each battery can provide a certain amount of power, but it might not last very long before you need to replace them. Now, if you connect multiple AA batteries together in a specific way, you create a battery pack. This battery pack combines the power and energy of all the individual batteries, allowing it to last much longer. Similarly, an EV battery pack is a mighty battery pack that supplies power to the electric motor. Not only does it provide acceleration, but it also determines the range and performance. The battery pack is usually positioned in the lower part of the vehicle, often underneath the vehicle or in the rear of the vehicle. The battery management system is an electronic system that manages the rechargeable battery to ensure it operates safely and efficiently. The BMS has both electrical devices and software working together. The electrical devices help measure and control the battery, while the software helps analyze and make decisions about how the battery should be used. It has a special module that allows the BMS to talk to other systems in the vehicle. The image displays two separate BMSs mounted on top of battery packs. Note that the location of the BMS may vary as the exact location depends on several factors, including the vehicle's design, the battery pack's cooling system, and the manufacturer's preferences. Most commonly, the BMS is built into the battery pack. Manufacturers may also integrate the BMS in a separate enclosure with its own cooling system, which can help to keep the battery cells at a consistent temperature. Manufacturers may also integrate it in multiple locations so that if one BMS fails, the other BMSs can still function and keep the battery pack safe. The primary functions of the BMS for an EV battery are safety, performance optimizations, health monitoring and diagnostics, and communication. Have you ever wondered how much charge is left in an EV? Well, that is where the state of charge comes into play. The SOC simply tells you the current level of energy stored in the EV's battery pack. It is like a fuel gauge for an EV. The state of charge ranges from 0 to 100%. It represents the current level of charge in an EV battery, with 0% indicating an empty battery and 100% indicating a fully charged battery. The SOC is displayed on the dashboard, infotainment system, or mobile application. Now, let us look at the battery range. If you have a fully charged smartphone with a battery life of 10 hours, this means you can use your smartphone for up to 10 hours before the battery depletes and requires recharging. The actual battery life may vary depending on factors such as screen brightness, usage intensity, and the number of apps running in the background. Similarly, an EV's battery range is the distance that a fully charged battery can power the vehicle before needing to be recharged. It is influenced by factors such as battery capacity, vehicle efficiency, driving conditions, and speed. An EV's battery range is displayed on the vehicle's dashboard instrument cluster or mobile application and shows a numerical value or a visual indicator that represents the estimated distance the vehicle can travel on a full charge. The main difference between SOC and battery range is that SOC is a measure of the current state of the battery, while battery range is a measure of the maximum distance that the vehicle can travel. SOC can change over time as the battery is used, meaning it decreases as the battery is used, whereas battery range is a more static measure, meaning it remains constant unless the battery is charged or discharged. Let us now summarize what we have covered in this lesson on key battery terminology. An electrode is a conductor through which electric current enters or leaves an electrochemical cell. It is a solid material, typically metal, that is in contact with an electrolyte. An electrolyte is a substance that allows electrical current to flow between the two electrodes. It is usually a liquid but can also be a gel or a paste. The lithium-ion battery is the primary energy source for EVs, storing and delivering electrical energy to power the vehicle. The battery pack consists of interconnected lithium-ion battery cells working together to store and deliver electrical energy to power the vehicle. The battery management system, BMS, manages the health and performance of a battery and ensures the safety of a battery pack that is composed of multiple cells. The state of charge, SOC, indicates the current energy level of the battery. The battery range represents the distance the vehicle can travel before recharging. By understanding these key terms, you will gain insights into the foundation of EV battery systems and a clear understanding of the essential terms related to EV batteries. This will enable you to comprehend the functioning and components of EV batteries more effectively. Thank you.